Hi everybody, I'm Brad Wilson. I'm a senior developer on the Microsoft ASP.NET team, and I'm here today to talk about advanced topics in ASP.NET MVC3. And I apologize in advance for having slides, but I'm getting old, so if I don't have slides, I won't remember what to say. First thing I want to tell you is we can take your questions. I know it's a live stream instead of a live meeting, so the easiest way to do is, if you have a question, is to go ahead and tweet it. Put my Twitter handle in there, which is @BradWilson. Put mvcconf in there. People hiding in the back, they'll type them in, and then I'll be able to see them on the advanced little teleprompter device over here, which makes me feel like I'm the President of the United States. So, onward we go. The first topic I want to talk about today is stateful filters. Stateful filters is a feature, it's something I blogged about a few months ago, telling people about how to keep state in their action filters in MVC. Interestingly, in MVC3, we've always sort of told people not to have state in their filters, but it kind of worked in MVC1 and 2. And in MVC3, we made a performance optimization that broke people who had stateful filters, which is one of the reasons I blogged about it a few months ago. So I wanted to show you some examples about how you can store state in your filter. And the important thing to remember, though, is that you're not going to store state in it like it's a normal class, because global filters, if you registered in your global ASAX, those filters are effectively singletons. But also the filter attributes, because the performance changes we made in MVC3 are also effectively singletons. So there's a few ways you might want to store state. Here's some examples. Per application, where you'd store it in the application object. Per session, you'd store it in the session object. Per request, you'd store it in HTTP context.items. Or per user, perhaps, you'd store it in a database. So what I'm going to show you is my first demo for stateful filters. And this is an example of how to do this. So let me show you my controller. So my controller has decorated on top of it a request timing filter. And the controller has a thread sleep 100 in it. And the view has a thread sleep 75 in it. So I just want to get a little numbers in there so we can see this, because this filter actually just does some timing. So if I'm going to show you how this works, I go to stateful filters. You can see it tells me the action took about 100 milliseconds to execute and result took about 80 milliseconds to execute. So if I keep refreshing this, you can see this is an example of per request state in the state filter. And so let me show you how this is written. Request timing filter takes an iStateful storage, which is an interface that I invented, and I'll show you how that works. And right now we're doing per request storage by default. And what we're doing is we have this stopwatch method, and we keep a stopwatch that we use during on action executing, on action executed. We have one stopwatch, and a different one for on result executing and on result executed. So we store those in our stateful storage. And because this is per request, you can see that at the end of this we take the results and we append some HTML into the response. So if I was to change this from per request into per session, all right, recompile this. I'll come over here, and you'll notice the first time the view results takes a little bit of time to run. That's because we're, of course, compiling the CS-HTML down. But the important thing you're going to see here is that every time I hit refresh, now we have cumulative numbers going up, because the state that I'm storing is now per session. If I was to take that into another browser, like, say, Firefox, we can see now that we have a different set of numbers over here. Now these numbers are cumulative with each other, but they're unaffected by the numbers over here in Internet Explorer. Okay, and so that's per session. So how did I do this? Definition of iStateful storage is pretty simple. I just wanted a get and also a get or add. So this is kind of the get me this, and if it doesn't exist, here's a factory on how to create it. So in the case of our stopwatches in the request filter attribute, I call get or add for a stopwatch, so I can make a new stopwatch. And that way, it doesn't matter whether we've seen one or not, we'll make sure we always have one. And then I have 3 implementations of this stateful storage pattern, one for per application, one for per request, one for per session. So we'll start with per application. And what I'm doing here is I'm actually going to http context.current application of key, and that's where I'm putting the value. And in the implementation for per request is storing it in http context.items. And then per session stores in http context current session. So just as simple as that, I've now created these utility classes that I can use inside of my filter and get the correct kind of per request, per session timing, anything that I want. Okay? So that's sort of the pattern that we want people to use when they write stateful filters. The second demo is a custom validation demo. And in MVC3, we shipped some new validation stuff called unobtrusive validation. We also shipped an unobtrusive AJAX support. And in MVC3, the unobtrusive AJAX and validation stories target jQuery. So we've been shipping jQuery with MVC since MVC 1.0, but all of our validation and AJAX stories up until MVC3 have been still targeting the ASP.NET AJAX library. Well, we got on stage with John Ressig and Scott Guthrie. We're at Mix about 18 months ago and said, you know, Microsoft is committed to jQuery. The ASP.NET team they're active contributors to the jQuery project now. And so this is sort of one of the results of that. Now all of our JavaScript moving forward for the MVC project is going to be based on jQuery. So when you unfold a new MVC3 project, you'll see that not only do we include jQuery, but our new features for unobtrusive AJAX and validation are written in terms of jQuery. So if you've seen custom validation before for MVC2, that will still work if you want to continue to use Microsoft AJAX. However, you may want to target jQuery, as we found most developers are actually using jQuery. So let me show you an example of how this works. But before that, one other thing to mention about MVC3 is MVC3 was the first version to target .NET 4. So when you write validation classes, you get new support based on data annotations in .NET 4. Primarily, the things that we're going to see today are validation with the validation context, and I'll talk about why that's important in the demo. But you also get support for iValidatable object, and we've also added iClient validatable to MVC3 to make it easier to do client-side validation without having to have an extra registration step. So we'll see some examples of how this all comes together. This is a custom validation demo. So if I go back to my browser, and I go look at custom validation, I have a simple form here with 2 values, and I have a custom validation on them, right? My model here has 2 values, the first one and the second one, and I have this new custom validation that I've written called greater than. And the greater than validation basically says value 2 needs to be greater than whatever the value is in value 1. So if I come over here and I type 12 and 16, that's okay. But if I type 120, it will tell me that the second one must be greater than the first one. So to write an attribute like this, using data annotations, you derive from the validation attribute class. And you implement a method called isValid. So the implementation of isValid for this goes off and gets the other property, and we're going to talk about what that is in a minute. That's a little bit of reflection magic, but this is sort of the core of the logic here, which is this value needs to be greater than the other value. And if it's not, we want to return an error message saying that these things are not correct. So I mentioned that one of the new features we have in data annotations 4 is this validation context. Well, in MVC2, if you were to try to write an attribute like this, you would have had to put it on the model class itself because you wouldn't have had access to any sibling properties. But the validation context class in data annotations in .NET 4 allows you to have access to the model object on which the property you're validating resides. And that's this validation context.object instance. So we can take the validation context.object instance, and we can go find the other property with reflection and go get its value, right? And because we have access to this now, we can put this property, the validation attribute, on the property. And because we can put it on the property, now it can contribute to client-side validation. Because part of the other issue that you have with MVC2 with something like this is that model-level validators can't participate in client validation. So because we have access to validation context, we can do this. And the other thing that makes this easy now is that we have this iClient validatable interface that we added to MVC3. The validation attribute can implement iClient validatable and say, I would like to participate in client validation. Now, implementing client validation is sort of two steps. One is you implement this iClient validatable, and you return a little bit of metadata about what it means to validate this thing on the client side. Now, the metadata that you always have to pass along as a validation type and an error message. The validation type, as we'll see, is consumed on the client side, and the error message is the error message to be shown. We also pass along an additional parameter here, which is the name of the other property, because just like we have on the server-side code, we use reflection to go find that other value. In jQuery, we're going to actually use HTML. We're going to use the DOM via jQuery to find the value of that other text box in the HTML form. So we need to know what the other property is so that we can write the client-side JavaScript. But you notice there's no actual JavaScript here, right? This is just a little bit of a description of what might happen if we wanted to take part in client-side validation. And in fact, if we look at the source for this page, what we will see is, turn on word wrap here, what we'll see is that each one of these inputs now has validation attributes attached to them. That's these data val attributes. So this is our new unobtrusive validation feature in MVC3. And what this is saying is, yes, this is a validated field. It needs to be a number, and it's required, right? So this is the first value. But now we come down here to the second one. We say, yes, it has validation, but it also has a greater than validator, and the other field name, which is value1, as well as number and required, which we sort of get for free because we know that they're an integer on the server side. But we don't actually have client-side validation running yet, right? If you were to look at this, you can see by looking at this, by looking at the Internet Explorer icon up here, you can see this guy spins. He's actually going to the server, right? This isn't client-side validation yet. So the other half of getting client-side validation to work is we have to provide some JavaScript. So if I was to look in my view, we'll see in the bottom I have this commented out section which includes a bit of JavaScript. And this is JavaScript that I wrote, which is the greater validator in JavaScript written against jQuery. So now when I rerun this, and I go to this page again, we'll see that we get client-side validation now. See, now if you watch the Internet Explorer icon here, when I click the Save button, no spinning. We're not going up to the server. It's all running on the client side. And in fact, you can see that we actually get live results out of this because it's client-side. Right? So we've now written all the server-side pieces. We've wired up the client-side JavaScript. Now all we need to do is take a look at what the JavaScript looks like. So when you write a validator for unobtrusive validation in MVC3, there are two things you need to do. The first thing you need to do is you need to write a jQuery validator plugin. And so this is our jQuery validator plugin. I've called it JQGrader. And this is a standard jQuery validation logic, right? This isn't MVC specific at all. This is exactly how you would write another validator for jQuery validate, whether you're using ASP.NET or not. So this logic is pretty much the same as a server-side logic, which is go find the values as ints and make sure that one is greater than the other. And this other piece here is the registration logic, which says, how do I turn those HTML attributes, the data-val-greater, into jQuery validate logic? Because there's no automatic wiring up, right? So this was the unobtrusive JavaScript piece that we wrote for MVC3. And this registration basically says, I'm looking for things which are greater. So we'll be looking for data-val-greater. I have one extra parameter, which is called other. And then a function that gets called every time it sees one of those in HTML. And that options object contains, for example, the other parameter, whose name other matches the string other up here. But it also contains the element that we're attached to, the form that we're attached to. So what we do is we parse out the information from the HTML, pass it along to this function. This function then gets everything that it needs, and it can wire up rules to jQuery validate. So if you were to write up a manual registration for jQuery validate, this is exactly what it would look like. You go and say, I have a rule. I want to call JQ greater against this parameter, this element as a parameter. And if you provided me with a message, I'm going to use that message to display an error. And I have a couple of extra helper functions here, which allow me to parse out this star dot, which we can is a sort of a more advanced topic. But when you have models inside of models, you can get names like foo.bar.baz. And if I was to just send out a name that said Baz, you wouldn't know that it started with foo.bar. So what we did for unobtrusive JavaScript support is we say, if you send down a name that is star.baz, what that means is take my name and parse off everything in the front, the foo.bar, and place it in front of Baz, because this is a sibling of me, no matter how deeply nested I am. So these two functions are basically the JavaScript that wires that up for us, so that we can send down star.value1 and understand that that is value1 with the same prefix as me. So this is the sum total of how to get JavaScript working in MVC3 to get both server and client-side validation. My next demo is a big one. The MVC forums are where we sort of encourage customers to ask us questions about MVC, and to report bugs, to ask questions. The team members are regularly participate on the forums, and probably about once a week I'll get a question that says, I would like to use a model that isn't a class. That is to say, I have a dictionary or I have a data table from ADO.net. And everything in MVC seems to be oriented around classes with properties. How do I bind that as a non-class model? In MVC2, we introduced 3 new features that were all very closely related to one another that make this possible. The first feature is model metadata. The model metadata feature allows you to describe a model. So the model metadata interfaces basically are given a type, or a type and a property name, and asked to return information about that type or that property. And it can be things like, what is the display name? What kind of template would you like to use? There's a whole bunch of stuff, and we'll go over some of this when I show this implementation. But the essential purpose of model metadata is, tell me about this model that I'm looking at. The second feature that we use is model validation. So of course you just saw model validation in play. In model validation, the essential call to validation is, I have this metadata that was given to me by a model metadata provider, and I would like to perform validation on this model. How do I do that? And the third feature we're going to use here is templates. Templates were introduced in MVC2. They're a way of saying, if you've seen HTML.editor, editor for, display, display for, that's the template feature. And much like validation, the templates are given a model metadata. And the question is asked, given this model metadata, how would you display this? Or how would you edit this? So we can combine all of these 3 features together with pluggable providers for model metadata, model validation, as well as utilizing the template system, which consumes all of those information. So this is going to be kind of a big demo. You'll have to bear with me a little bit here as we sort of set the stage. So we come to non-class models. We can see this looks like a pretty simple form. It has 2 entries, special foo and fancy bar, and they have values already, 42 and Baz. But what's interesting about this is if we go and look at the controller, this is our model. Our model is a dictionary, and it has foo and 42 and bar and Baz as its values. So normally if you were to pass this along, what you would get is a very uninteresting display, which looks like a couple of square brackets, which had foo42 bar baz, because the system really doesn't know what to do with dictionaries. Because you have to remember, as we ship MVC, the default way of dealing with models is classes with properties. So it looks at the dictionary and says, there are really no interesting properties hanging off of a dictionary that I can use to get information. However, because we have this working, obviously, the way this worked is I wrote a provider that would allow us to do this. So the area registration for this, I have a little Fluent registration system that I wrote, which says, whenever you see the type my dictionary, which if we go back and look at the controller, you can see that this is the dictionary we're using, the my dictionary, which is just a dictionary of string, that's all it is. Whenever you see my dictionary, manufacture a property named foo and a property named bar based on values inside the dictionary with keys of foo and bar. And here's the display name, special foo. So if I was to say special foo for you, make that little change and come over here and refresh, we'll see the page says special foo for you. And if we go look at the view is going to look pretty standard. The view really doesn't know that it's dealing with a non-class model, other than the fact that its model is currently a my dictionary. So we have html.label, we have html.editor, and html.validation message. But you'll notice what we don't have here is label for, editor for, and validation message for. Obviously, those functions require a strongly typed model because they take expressions and they manufacture properties out of that. So if I was to say label for, given a model, you'd see that the model that it knows about is the dictionary. It has no idea what things are in there. So instead we use the string versions of these, and we just say, trust me, there will be a property named foo. Find its label, find its editor, and find its validation message. So there's a question on this. GSO-GOL, have no idea how to pronounce that. Any plans on having anything that lets you define via attributes to be done via Fluent interface with fine-grained control? So in my example here, my registration is a Fluent registration. The reason for that is the dictionary itself really has no properties from which I could hang attributes off of it. But there's no reason you couldn't write your own metadata provider to do a Fluent registration, even if you were using strongly typed models. And in fact, I'm pretty sure the MVC Contrib project has something like that. There are definitely Fluent validation systems out there that can be plugged into MVC. But what's different about mine is that I'm not doing it with classes. Most of the ones I've seen they use classes and they use lambda expressions very much like the view, the label for, the text box for. And they wouldn't work with dictionaries either. So the purpose of this experiment was to see what it would look like if we were to use dictionaries instead of a class. So anyway, back to my view. So my view has a simple label, editor, and validation message. It really doesn't know anything about the fact that it's using a dictionary, other than the concession that it's not using the lambda syntax for finding labels, editors, and validation messages. But if I were to pass a class in here with properties named foo and bar, it would work equally as well. So in that sense, it doesn't really understand that this is a dictionary. The way that this works is I've actually replaced 3 things in the system. The first thing I replaced was a model metadata provider, and I wrote my own dictionary model metadata provider. So if you remember back to the slides, the model metadata provider is the thing that says, given a type, please describe for me the things about this type, including what its properties are. So when we say here in for property in this Fluent registration system, what we're saying is I intend there to be a property named foo. And if I hit dot, you can see that there are several things available to me that I can use. And a lot of these things are properties mirrored on the model metadata class. So should I convert empty strings to null? What is my data type? What is my description? What is my display format? What is my display name? Right? Edit format. So there are several things that are available here that are all hanging off the model metadata class. And in fact, if we were to look at the model metadata class, you would see many of these same properties available on the model metadata class. So I've just made fluent registrations for all these property values. And my model metadata provider then reads these fluent registrations and turns them into calls to set those properties on the model metadata. So my model metadata provider, when it sees my dictionary, says, aha, that is a type that I know about. And I'm willing to provide you all the information about how that works. The other thing that's hanging off of here is also validation. So for example, we have required as a required validator, right? So we can now say that this field is really important. So if I now recompile this, come back over to my browser, and refresh. If I was to take the value out of here and try and submit it, it would tell me that this field is really important. And in fact, you can see that with the validation that we just shown, you can see we have data val required. This field is really important. So from the standpoint of the JavaScript, from the standpoint of jQuery, it doesn't really know that this information came from my Fluent registration system as opposed to the required attribute. And that's because of the architecture of the way validation works on MVC is the server-side implementation is decoupled from the client-side implementation. And the decoupling takes place through these attributes, data-val-required. So because I have a registration for required, which says this field is required, here is its message, MVC sees that and can automatically generate this HTML for us that'll get wired up by our jQuery. So how does this work? Because this is kind of cool looking at it, but how does it actually work? So the metadata provider, what we do in this Fluent registration system is, there are a lot of types here, so hang on to your seats. The way this works is we actually have a, let's go to metadata first. And we have a thing called a type registrar and a property registrar. These are sort of how my Fluent registration stuff works. So if we're to look at for type, we see that it returns a type registrar. And for property, we see that it returns a property registrar. Now, display name is an extension method. You can actually see that in extension in the tooltip. So we've written all of these as extensions off of this Fluent registration system. And the way that we do that is metadata property extensions. And all I've done here is I've set up a system where you register what's called a modifier. So it'll say, I've created the model metadata, and I'm giving you an opportunity to modify it by passing me a lambda expression, which is an anonymous function, by passing me an anonymous function that will modify that metadata. So when someone calls convert empty string to null, what that means is I register a modifier that says when the metadata has been created, I will set its convert empty string to null value into whatever you told me. So there's one of these for all the things inside of model metadata. Data type name, description, display format string, all those methods we were just looking at are all simple sort of one-liners modifying the metadata. So I've taken the Fluent registration information and stashed it away until such a time that somebody comes and asks me for the metadata about that object. So there's a question from Josh Dean. What is the benefit of non-class models? That's an interesting question. So if you have a choice, my answer is you definitely would probably want to use class-based models whenever possible. But not everybody has that much control over their architecture. They may be using an older system where there weren't classes. They may be under some restrictions about, maybe they don't have an object relational mapper, and so they prefer to use a data table because they've been doing ADO.NET and that's where they feel comfortable. Or it could also be that the schema is not known ahead of time. There are a lot of data applications where you can't accurately describe every permutation of the data in a class at compile time because you don't know what it is because it's not going to exist until runtime. So all these cases are cases where you'd wind up using a non-class model like a dictionary or a data table because you may not be able to actually express your data in terms of classes. So that's kind of one reason why you might want to use something like this. So to go back to what I was talking about, how do we get this actually into the system? Well, we wrote a model metadata provider. And implementing a model metadata provider basically means answering three questions. And the three questions we need to answer are get metadata for properties, get metadata for property, and get metadata for type. Right? So this is an anonymous, or an abstract class that's part of MVC. So if you implement a model metadata provider, you need to be able to answer all three of those questions. So the first thing that we're looking for is get metadata for type. And in our dictionary model metadata provider, for get metadata for type, we're going to be looking for whether or not they ever made a mapping for that model type. And if they didn't, then we actually delegate to the original model binder, or the original model metadata provider. And that allows you to sort of mix these classes along with stronger type models. Otherwise, we find this and we actually apply all of our modifier rules to the type. So there are metadata things that you can register on the type itself. Right? If I was to go over here and say from the for type, there are extension methods, particular, thought there was one. Property, I thought there was one for display, but I must not have put it there. But you could have extension methods hanging off of for type that would modify the model metadata. So once we found the type, we found my dictionary. The system is going to say, okay, my dictionary, great. The model metadata provider, in this case, actually also returns a special model metadata class that we've written. And the special model metadata class, the primary reason we need this is for this properties object. Because the normal model metadata system is going to be using reflection to find its properties, but we don't actually have that. In our case, we have to go back to our Fluent registration system and find out about all the properties available for our type. So that's the other thing the model metadata is going to do. So the first, we've been given a dictionary to the view. The view is now starting to display things. The system is going to say, I need to find out model metadata about the dictionary itself. So that would be the get model metadata for type. Now it's going to be looking to present labels and editors for the individual properties. That's going to be a call to get metadata for property. So in get metadata for property, you're given the container type, which in our case will be the dictionary, and the property name. And the implementation of this is, again, relatively simple. We go ahead and create a dictionary model metadata based on that, and then apply all of our modifiers. So because we've set up our Fluent registration system as a bunch of method calls, all those method calls go one at a time and modify the model metadata after it's been created. And then we can return that model metadata back. So just as in the type case, now we have property-based model metadata, which includes things like display name. And that's how label works. So label, the implementation of label, if you were to look inside the MVC source code, says go get me the model metadata for this property. And given the model metadata, I'm going to call get display name on it. That's how it works. So this is the model metadata provider. This is the first part. This gets us information about the model itself, including the values that are inside of it. So this is how we can turn foo into 42, and this is how we can turn bar into baz, because we've implemented this model metadata provider and this model metadata class. The second part of this is validation. So just like we had extension methods hanging off of type and property registrar for model metadata, we also have them hanging off for validation. And for simplicity's sake, I just re-implemented the for data annotations validators, which are normally provided as attributes. But in this case, since we can't use attributes, we register them with these Fluent methods: range, regular expression, required, and string length. Implementing a validation provider is a little bit simpler than implementing a model metadata provider, in that you only have one question to answer, which is, given this model metadata in this current controller context, please tell me what all the validators are. Right, so this is the second part. This is how we can get required validation, including client-side validation, because this standard API, this model validator class, is something built into MVC. MVC doesn't have any intrinsic knowledge of data annotations, except for the fact that by default we have a data annotations model validator provider as our default validator provider, and a data annotations model metadata provider as our default metadata provider. But other than that, nothing in MVC knows anything about data annotations. So this model validator class is a small abstraction on top of validation, which is essentially validate this object and return results back, as well as get me the client rules so that I can wire up client validation. So our implementation of this is relatively straightforward. Again, we look to figure out whether or not this is something that we know about. Is this a class that we saw registered? And if it is, I go off and get the validators that have been registered into my Fluent registration system. And one by one, I turn those validators into model validator objects. Now, in this case, the extension methods that we used for registering these, we return model validator objects. Well, it turns out with the data annotation system, we already have implementations of model validator for all of these four things. All I had to do was new up the range attribute adapter for a range attribute, regular expression attribute adapter for regular expression attribute. Now, this was just an easy way for me to do this because I already had these attributes, but you could write your entire own validation system here written as model validator classes. Because these guys, these range attribute adapters, already understand how to do client-side validation, right? They implement iClient validatable, then that means we can participate in client-side validation even though we went through this Fluent API. So I see a question on Twitter from Control-Shift-Brian. Aren't we violating the drive principle when we have to write validation logic in JavaScript and C#? That's a good question. We're not necessarily violating the drive principle. It does look like we're implementing two different things in two different ways because it turns out we actually have two different validation systems. If, for example, we had JavaScript on the server instead of C#, that doesn't necessarily mean that we'd be able to reuse the code. It would make it a lot more likely, but the code would still actually exist in both places. It would exist in the server and in the client. So in a sense, we do have two implementations of validation, one for client and one for server. The fact that there are different languages of the same language doesn't change the fact that we need that code in both places. So I'm not sure that I would say that this is a violation of dry. And dry, for those who don't know, is it's an agile principle, DRY, don't repeat yourself. So that's a great question, though. Thanks for that question. Okay, so we've now got validation wired up through our Fluent interface. The last piece, as it turns out, I had to also write was a model binder. So model binders in MVC are the things that are responsible for taking values from a request and turning them into action parameters. So in our controller, we take my dictionary model as an action parameter when we get a post back. And it's the model binder that's responsible for turning the values, foo equals 42 and bar equals baz coming from HTML. The model binder is responsible for taking those values and putting them into an object. Well, we don't have a dictionary model binder by default because our model binder is designed primarily around using properties against a strongly typed class. So I also had to write a model binder. And writing a model binder means writing a model binder provider. And a model binder provider is a simple one method interface which says, given this model type, are you able to provide me with a model binder that understands it? So once again, we go back to our mappings list and say, is this something we know about? If it is, then we're going to give it our new dictionary model binder, which we just wrote. Otherwise, return null, which tells MVC, well, we couldn't figure out what it was, so keep looking. And we register that inside of our area registration. All right, that's the third thing that's down here, which is we add a model binder provider. Now, this is not the default model binder. It is our own model binder, so we just add it to the list. It says the model binder system in MVC has a list of model binders that may or may not be able to answer the question, and then one which is the default. So if you go to binder providers, and then you say default, whoops, sorry. There is a way to register a default model binder off of here, which is escaping me at the moment. Anyway, so we've registered our own model binder provider, and this model binder is this is actually probably the most complicated bit because I actually wanted to reuse the default model binder logic because, as it turns out in MVC, the execution of validation code happens inside the model binder. Because what we really want to know is when we write our controller, we really want to know whether this thing is valid, right? So when you write this, you would normally write if not model state.is valid. And you would do something different if the model state currently isn't valid. The ability to do that is because the model binders understand how to run validation. So I wanted to get that validation logic. So writing the model binder for this meant I wanted to override the default model binder. And this code is a little bit complicated, as you can see. It's probably more complicated than it needs to be, but we're kind of aware that the model binding situation is a little complex, and we have an alternative implementation inside of MVC Futures, which is much simpler to plug into. But I wanted to show this example as a plugin directly into MVC itself as we ship it. But you know, the primary thing we need to do is sort of twofold. One is bind model is going to bind the dictionary itself, and this is essentially the exact same code that's normally in the default model binder, where we go through and get the model properties and bind those properties. And on-model updating and on-model updated are the events that hang off of the default model binder. So we want to continue to call those things because a lot of the validation happens there. But our big override here is get model properties, where we're going to go off to our Fluent registration API and ask it for all the properties that got registered so that we know how to return these fake property descriptors. And these fake property descriptors essentially set for get value and set value assume that you have a dictionary that it can get and set values on. Property descriptor is an extensibility point built into .NET around reflection. It's primarily used by Visual Studio, but we use it in MVC in places like this because property descriptor is an abstract class that's intended to be overridden. So in this case, I don't have real properties and I don't have a real class, but I can implement a property descriptor that makes believe like I have a real class with real properties. And this is how the whole system sort of works, because MVC is all written on top of these abstractions. And that is how that all works. So as I promised, that was going to be a big demo. At the end of the presentation, I'll give you a link to slides and code, because obviously you couldn't read all that code while I was going through it. But hopefully I've given you enough of a surface look that you can sort of dig deeper into solving this problem for yourself if you think you have this problem. So my next presentation is Custom Action Invoker. This is an extensibility point that's been in MVC since MVC 1.0, I believe. And it's one that most people don't know about, although Javier, who is 2 rooms over, knows a lot about it because MVC Turbine, the project that he works on, uses action invokers. So a custom action invoker allows you to override several different things in the system. It allows you to sort of determine how you're going to map action names into methods. And the way it does that by default in the controller action invoker, which we're going to override here in a minute, the controller action invoker uses reflection, but it also uses the action name attribute to help you do an override for that if you need to rename an action so that it doesn't exactly match its own method name. So that's one of the things Action Invoker does. Another thing Action Invoker does is actually finding the action filters on an action. So when you decorate a controller class or an action method with a filter, it's actually the Action Invoker that's responsible for going out and using reflection to find those things. And then finally, how to handle return values is the last thing Action Invoker does. That's actually the thing that we're going to show in this demo, is how to handle return values. So this custom Action Invoker demo, the presentation after mine is going to be Glenn Block, and he's going to be talking about WCF and HTTP. And one of the things he's going to show is content type negotiation. So I just want to preface this by saying this is not a replacement for WCF, but this is just an example of showing you how you can use an action invoker to do some of the kinds of things that WCF does for you. So if I look at my controller, I have a model here, which is a contact model, first name, last name, and age. And I have a content negotiation controller, and I have a single method which returns an instance of this contact model. So if I go and look at this in the browser, we will see that this is a simple HTML display. Contact has HTML. Okay, we haven't done anything particularly exciting about this. We're returning a view for this model. What would have happened? Now notice the return type here, I set it as object. I cheated ahead a little bit, but normally people have action result. What was to happen if I was to actually just return that object itself? So what you see is the default action invoker in MVC will take an object and call toString on it. Well, this isn't particularly interesting. mvcconf 2011.areas.contentTypeNegotiation.contact, right? That's just the type name. So we want to have something be a little more useful than that. So what we're going to do is we're going to hang out with some dragons here. We've overridden the initialize method in the controller, and we're going to put in our own action invoker, which is a content type negotiating action invoker. And the first thing I'm going to do is I'm just going to rebuild, and I'm going to refresh this page. And we're going to see that we got our view back. So content negotiation is an HTTP feature. There's a header in HTTP called accept. And accept is a header that you use when you contact a server to say, these are the formats I would prefer you to send data to me in. So by default, when you return an object out of this browser, it's going to return an HTML. That's how we've written this action invoker. But we can also get it to ask for JSON and XML. These are the features that I've wrote. So this, what you're going to see here is content type negotiation through the accept header in HTTP as opposed to changing the URL. All right, so we fall back to HTML as a default. We return our view result given that model. But how do we get this to do JSON and XML? Well, you can see that what I'm doing is I'm looking for an accept type of accept JSON. Now, as I said before, this is nowhere near as advanced as the stuff that's in WCF. This is just an example to show you the kinds of things you can do with an action invoker. Real content negotiation is much more complicated than this. However, let's see how this works. So I'm going to grab Fiddler, one of my favorite debugging tools. Let's go ahead and clear our log. We've been running Fiddler the whole time. Let's go ahead and refresh this page. And we'll see in Fiddler we had a request for content negotiation, and then there's our CSS and our JavaScript. Great. So if we look at content negotiation, you will see we have an accept header here, which is accept **, which actually isn't great, because that means I understand every format of every type ever invented by anybody. But that happens to be what Internet Explorer says. Give me whatever you want, and I'll figure out what to do with it. So as a result, we have sent back HTML. However, what you can do with Fiddler is you can actually get it to build a new request. So we're going to start with this request as a template. This was our original request. And if we change our accept header, let me zoom in here so you can see what I'm doing. If we change our accept header to application JSON, and then execute it, you'll see that we have a new request that happened here. And the resulting HTML that came back wasn't HTML. We have a JSON version of that object. Similarly, if I was to go to the request builder and I was to say, I'm interested in text XML, and now execute that, you'll see that we get back XML. And if we look in the raw, we can see that we've gotten an XML back. So by using the accept header in HTTP, we've told it, these are the formats that I would like to see data in, JSON or XML. And the code here for JavaScript serializer, this is how we get JSON, this is how you get XML. That's not really all that exciting, but what I wanted to show you here was the action invoker as the way of doing something like content negotiation. And now, instead of returning a view explicitly from our controller, instead, we just return the model itself and assume that the content negotiation will take care of what form the user wants to see that model in. Okay, so that's that demo. And the final demo today is routing constraints. So most people know that you can have routing constraints in MVC. Routing constraints limit route matching. They limit it both inbound and outbound. So when you're constraining an inbound route, what you're saying is a request has come in, and I have this URL, and I need to understand what controller and action I would like these things to be mapped to. So I put the word handler here, but the reality is that in MVC, handler means controller and action. Routing, of course, doesn't really know about MVC. Routing just looks for implementations of IHTTP handler. So in MVC, we have an IHTTP handler, which in turn turns a controller and action name into calls to your action method. Routing constraints can also limit routes on the way out. And that is when you have route values like controller and action name and other things, it can say whether this is an appropriate route to match. It's important to note in routing that in both cases, your routes are registered top-down. And the top-down logic says the first person who says, I am okay, will win. The built-in MVC as a constraint, and actually built into the routing system as a constraint, if you pass a string as a constraint, you can say that is a regular expression. So people will commonly do, like when they have an ID in their URL, they'll put, \d+, meaning the ID needs to be exactly one or more digits. So a regular expression can be used to constrain a route. But you can also implement the iRoute constraint interface. And the iRoute constraint gives you a lot more control than a regular expression. You actually get to inspect the request information and the URL generation process and say whether something is appropriate or not. So I have an example here of a routing constraint. And this routing constraint, let's actually look at the area registration first, because this is more interesting. This is our routing constraint here. It's an MVC method constraint. And this implementation of iRouting constraint says only allow it if it matches this HTTP method. So in this case, we have get, put, post, delete. But the interesting thing is we have, if you look at the URL portion of all these routes, most of them just say route constraints or route constraints with an ID, right? So if you're familiar with sort of the RESTful URL pattern, this is kind of reminiscent of the RESTful URL pattern, where you can say, if I'm saying get against route constraints, what that really means is I would like to list everything. However, if I say put against route constraints, that means I would like to insert a new something of that. So we have the sort of the standard CRUD operations, list, insert, update, and delete. And they map to the 4 HTTP methods, delete, post, put, and get. We also have 2 versions of routes that will actually return forms. So in a RESTful world, form isn't necessarily a representation of an object. In our case, it's UI. But we had to have URLs to get UI because I'm showing all these demos in a browser. So in this case, to get the insert form, you go to route constraints new with a get, and to get the update form, you can just go to route constraints ID with a get. Now I had to tack new on here because obviously route constraints by itself with a get is a list everything. The implementation of the method constraint, implementing a route constraint is implementing this one match method. And it gives you information about the request that's underway, including the HTTP context, the route that you're attached to, and parameter names, and a lot of other stuff that's not as germane to the conversation today. But for us, basically all we want to do is we want to go after the HTTP context and get the HTTP method override and say, is this something that's allowed? And you notice that browsers normally can't do post and delete, or put and delete. They can only do get and post. So we're also going to combine this with an MVC feature that allows you to do post, but trick MVC into believing that it's a put or a delete. Okay, so we go and look at this in the browser, and this isn't particularly exciting here. The routing constraints, this is a list of people. If you want to edit, you can edit a person, you get the form, and you save this, and these changes persist. Right, so this isn't particularly exciting as a UI. However, the route constraints make it interesting. When I write the controller, I wrote the controller with names like list, insert form, insert, update form, and update as a way to differentiate them. And you notice that the action names don't necessarily match the URLs. So unlike the normal pattern of having a controller and action name specifically inside the URL, we have this case where I've mapped them a little closer to their sort of CRUD names. And so the code that's in here really is sort of standard object manipulation code. It's not really all that exciting. The constraint is the interesting thing. It allows us to have URLs like route constraints to list everybody, route constraints /1 to edit person number 1. But also, if you were to look at the delete link, if we look in our tool tray, or look down here, let me make this a little smaller so we can see it all at once. Right, so when I hover over this, you can see that the actual URL he's going to dispatch to is simply route constraints 0, 2, and 3. Right, this is just standard delete routing, and the way that this works is we use from our view, we use feature of MVC. Let's look at list. This HTML.HTTP method override for delete, which says this form that we're going to post is actually a delete, right? And what that ends up doing is sending down an extra hidden field here. Right? We have a form with a post that has an HTTP method override hidden value of delete, and MVC sees that and understands that that's actually a delete, and that's what we're keying off of on our routing constraint. So that's an implementation of custom routing constraints. I have one more demo, which I'm not going to have time for. It's an async controller demo, so if you need to understand how to do async controller stuff, you'll be able to go to my blog and grab the slide deck and the sample code. The first link here is the speaker rating link. Please click and rate. The second link here is a shortened link off to my blog, and it has a link to the slide deck and the code for today's examples. And with that, I will